Good morning. Myself Salini, currently pursuing B Biomedical Engineering at Erode Engineering College. Now we are going to see about one seminar is assistive technology. So this is our topic. Our topic is smart prosthetic limb using sensors and AI for natural movements. It is nothing but when any other accidents or sometimes injury our hand or leg, so that time we are using the prosthetic limb hand like arm sensors. So this is the introduction. Introduction is the prosthetic limbs or artificial device used for replace missing body parts. So we are replacing that parts using hand, arm, legs. So these types of parts sometimes having any injury or accidents. So that time our natural body part does not properly work. So that time we are removing the part. We are adding these types of prosthetic limb parts help restore mobility and independence for the amputants. Traditional prosthetics are mostly mechanical and lack of intelligence. Recent advancement in also using in sensors and AI in many types of recent prosthetic limbs, we are also included in the real-time and sensors like activities. So the main objective and motive, the aim of this prosthetic limb is achieve the human normal hand like arm structure activities functions. Then this is the block diagram, the prosthetic hand. This is the wearable note, and these types of in traditional devices also and advanced methods we are including the Bluetooth link and elastic armband. So the elastic armband using these types of armband for the EMG sensors. The EMG sensor it's nothing but it measures the electrical activity of the muscles. Then now the problem statement is conventional prosthetics lack feasibility and adaptability. Movements are not smooth or natural, limited feedback to the users, and required for high physical effects to operate. Poor user satisfaction and comfort. So these types of in these real-time problems. Now how we can overcome these types of problems. So let us see about. So the objective is a design an intelligent prosthetic limb system, integrated the sensors. Already we see this. This is in one introduction diagram. Use AI to interpret users' intention and achieve smooth and natural movements, enhance comfort, usability, and efficiency. Overview of the smart prosthetics. Combine electronic sensors and artificial intelligence, detect the muscle activity and environmental conditions, provide real-time response to user input. It is using to continuously measures and given a real time of response. Can learn and adapt to user behavior, improve overall performance and accuracy. So, what types of sensor we are used in these types of prosthetic limb system? EMG sensors, pressure sensor, accelerometers, gyroscope, and flux sensor. EMG sensors, we know the muscle signals to detect the muscle signal, and pressure sensor measure the grip force. So sometimes we are taking to one object, like that object is in a one water bottle. So that time how we are give how many amount of frequency or tightening. So how many pressure we give that object. So then only we are measuring. We are using pressure sensors. Accelerometer detect the movement and orientation of their uh, artificial and prosthetic limb. As gyroscopic track the angular motion in our hand. It move from the some degree angular motion only. So the time we are continuously measuring these types of gyroscope and flux sensors. The EMG sensor function capture the electrical activity, use the comfort prosthetic movement, provide the initiated control for user, essential AI based decision making. The role of AI in prosthetics: use the machine learning algorithm, identify the patterns, predict the intended movement, adaptive overtimes with users training, enable the personalized prosthetic control. The system architecture: this is the main how the system is works. So now we are looking the system architecture. Input: the input of our system is sensor data collections. So we are already know what types of sensor: pressure sensor, gyroscopic sensor, accelerometer sensor. So based on these types of sensors we are measuring the census data collection. So we collect the data, then processing the data using microcontroller and AI model, artificial intelligent model. So these types of processing sensor, processing the microcontroller and AI microcontroller, we are also using real time of data. Then output is motor moment. So we measure our brain signal give the signal of prosthetic limb, how the limb is work. So that time of we are giving the input and then processing the signals. So we receive the output is motor accelerometer. In sometimes the systems give in a motor or acceleromoment. um, Rarely it is given two types of movements. Then the feedback is continuously monitoring. What type of feedback given the prosthetic limb to patient, then how the limb is works. So it is does not cooperate the patients. So we are recorrect and reprocessing, give the data or newly and adding some new data. So then only we are feedback continuously monitoring and a closed loop system for the accuracy. So closed loop systems, then only the input data and giving the processing data, it is the continuously work in a one loop systems. Then hardware component. What types of hardware components we are using? Mainly we are using in a five types of component. One is the microcontroller, ESP32 and a system controller, servometer, movement of joint, battery, power supply, then sensors, data collections, display. Optimal, the system status. What types of status the system is work. So these types of commands showing we are using the display. The display is nothing but it is the very simple. We are using the LCD display. Then the software design. These prosthetic limb we are also included into the hardware and software design. So previously we are seeing about the hardware design. Now we are looking about software design. What types of software design? Using the data acquisition for the sensors, signal filtering and noise removal. Signal filtering and noise removal. Noise removal we are using the bandpass noise and notch filter. Bandpass noise we are using high noise and low power noise. High power noise we are reducing in the unwanted data are collected from some types of sensors. The sensors is continuously monitoring. So that time we are does not omit some data. So then only we are using these types of noise system and a filtering system, smooth sharpening filtering and a smoothing filtering. We are selecting any one filtering to filtering these activities. Then they feature extraction from the signal. What types of signal get the sensors? So that signals are feature extraction, extracting and giving the stage by stage. So briefly extraction, the extraction only we are know what type of activity doing the limb activities. So AI model training and prediction. Then detect we are detecting the activity model. So we are giving the training for the data. What type of training? The training is AI model, artificial model and prediction, motor control and programming. The motors are automatically controlled and it react only the AI model. Training prediction give the what type of feedback the models are giving. So then only the motor is automatically activated and it come their normal position. Then working principle is the user attempts movements muscle signals generated. EMG sensors capture the signals, AI process and interpretation signals, microcontroller sends command. Microcontroller send also command, and motors perform desired movement, feedback improve accuracy. The flowchart. The flowchart is the main part of our seminar. Our title. Start the system. The system is start. Initialization sensors. The sensors collect the data and read the sensors data. What type of data they are getting. So that time we are read the data and give the process signal. So the collecting data are sent to the process signal. Apply the AI algorithm. AI algorithm is nothing but what type of algorithm, like random forest algorithm, KNN. So these types of algorithm we are inbuilt the data signals and processing generated the output. These types of algorithms we are using get in a one continual and noiseless signals. So then it's generated an output. Also control accelerator. The control accelerator, it is the activated in a position. That's all about flowchart our title. Advantages. Main advantages of these: produce provides natural and smooth movement, reduce user effect, improve precision and control, adaptive to user habits, enhance quality of life. So in these types of harmless, handless and legless patient does not depend any other human beings. So the type of human beings does not continuously and regularly whenever the patients does not feel very better, they are also feel in a very guiltiness or very loneliness. So these types of prosthetic limb using to enhance the quality of life and also survival of the independent life. They are easily mingle with normal life people. They are also running their life is not normal people, like moving, taking object. So these types of activities. Then the application. These types of prosthetic arm, which places are we are applying? Artificial arm and legs, artificial legs for walking assistance, rehabilitation therapy. Many rehabilitation therapies we are using these types of prosthetic arms, and assistive technology for the disabled and individuals. Assistive technology, it is also used in one assisted device like technology. Disabled peoples, the disabled peoples does not activate in a um, independently. So they many times they are dependent. So these activities given a individual activities. Challenges. So we are developing these prosthetic limb. What type of challenges we are faced? These limbs having many advantage and technology. So this is very high cost and advanced components, complex system integration, limited battery life, signal noise and accuracy, need for the users training. Experimental result. Give these types of on prosthetic limb. What type of experimental result we are reaching? Faster response and compared to the traditional prosthetic. The traditional prosthetics we are having many problems facing their lives. Are the components rate are very high. The components weight is very high. So that time we cannot handle easily. So these types of problems we are facing their lives. And accuracy, higher accuracy, the movement detection, improved grip controls, position feedback from the user, efficient real-time performance. Future scope. Integration, the BCA interference. We are also so these systems in currently we are creating the systems. It's only integrated in a prosthetic limbs and sensors AI. And in future scope, we are also integrating the BCA interference, brain computer. What type of brain signal is giving to the normal human muscles? So that type of activities is also directly given these types of prosthetic limb. So how the limb is works. So we are also excited to integrated the BCA system also in our project. Use of cloud and IoT for the remote monitoring. Also we are using the clouds. So cloud mainly we are using in a data collection and storing. IoT is the real-time monitoring. Development of the lightweight materials. Also right now we are also developing a very lightweight of materials, and in futurely we are using a very light materials. The advanced deep learning models and sensory feedback. Conclusion. The prosthetic, smart prosthetic are major advantage in healthcare. The very advantage, and rarely these types of sensors are using. It is the very needed product. So we are generating these types of project. It gives in a good one market selling, and it given a one good business idea also. The AI enable natural and intuitive controls. Sensors provide accurate data for the moment, improve the independence and confidence of users. Future innovation will be make them accessibility. These types of future innovation will make them the accessible. In every normal persons also access these types of advanced materials. That's all about our today's topic. Thank you.